Okay, given the graph of this polynomial, we ask, is this polynomial even or is it odd? Is it even or is it odd? So what do we need to do to answer that question? Well, we remember our favorite functions, x squared and x cubed. So here's even behavior, here's odd behavior. This is positive, this is negative, this is positive, this is negative. So we look at the end behavior. What do we have on that graph that I gave you? It's up to the left and down to the right. Up to the left and down to the right. So if we look at our picture, up to the left and down to the right looks like this one. If that's the case, we know up to the left, down to the right we conclude that the degree is odd. That means the highest power is odd. And the leading coefficient is negative. Okay. See what else we have to answer. So is the degree of the polynomial odd or even? We said the leading coefficient is odd. Excuse me, we said the degree is odd. Leading coefficient positive or negative? We said negative. Now, what is the smallest possible degree? To answer that question, you have to count turning points. Turns here, 1, 2, 3, 4. It has 4 turning points. So if it has 4 turning points, you've got to add 1. 5 is the lowest possible degree. Could be 5, could be 7, could be 9, right? It's odd, so it can't be 6. Smallest possible degree here would be 5 with 4 turning points. Again, let's identify them. 1, 2, 3, 4. Where it changes from going up to going down or from going down to going up, that's a turning point. Your smallest degree is to add 1 to those. Now, how many real zeros does this polynomial have? How many times does this polynomial cross the x-axis? Just has 1. I don't know, 1.8, somewhere in that range. It only crosses 1 time. So the fundamental theorem of algebra tells us if it's order 5, we should have 5 complex zeros. Well, if only one of them is real, that means the other 4 would have to be complex. That would be pretty difficult to find, but that's what this graph is showing us.